In this video, we're going to look at question 11 of the free response portion of the Chapter 3 practice test. Now, question 11 says, Sarah's parents are concerned that she seems short for her age. The doctor has found a record of Sarah's height. The first prompt asks us to make a scatter plot. Now, before I do that, I want to look at the table. Now, we're tempted to say right away that the explanatory variable is going to be age based off the table. And I'm going to label it as age in months. And we're tempted to say the response variable is going to be height, just based off the table itself, not the prompt. But we should be able to recognize it, height in centimeters, based off the prompt. Her parents are concerned that she seems short for her age. So we're looking at, does age predict height? So age is our explanatory and height is the response, but we can even see it just from this sentence as well. So we're asked to make a scatter plot. So let's do this. I'm going to put my y-axis, I'm going to put my x-axis, and I'm going to label. I'm going to put age on the bottom, on the explanatory variable, the x-axis, and I'm going to label it as months. So always label graphs, and then my height is y-axis, and that is in centimeters. Well, we have the labels, but we don't have the intervals yet. Age is from 36 to 60. So let's start then at, we'll make it easy, 35, and I'll go by 5. So 35, 40, 45, 50, 55, and 60. I have my age. Now height starts at 86 and goes up to 95. So I'm going to start at 85, and I know the max is 95. Halfway in between is going to be 90, and I can actually make this 87.5 and make this 92.5. So there's my intervals, my scales are good, my height on the y-axis, my age on the x-axis, and now I just do my best with labeling. I have 86 for my y, 36 for my x, so 36, 86, 48, 90, 51, 91, 54, 93, 57, 94, and then 60, 95. Now my points might be off a little bit, but for the most part, it's a pretty good graph when it comes to eyeballing it. And the idea when you're graphing, you're sketching a graph, is to make sure you have everything you need, the labels, the intervals, and just get as close as you can to the points. Now we're going to look at part B. We're asked to use our calculator to find the equation of the least squares regression line. So for part B, so here's A, we'll look at B right here. I'm supposed to use my calculator. So to use the calculator, I'm going to go to Stat, Edit, and in my L1 and in my L2, I already have the explanatory and the response variables. I have my age and I have my height. What I'm going to do though first is I'm going to make sure I hit second stat plot. I'm going to make sure plot 1 is turned on, and it is. It's set for scatter plot. L1 is my X list, L2 is my Y list, so I'm good there. The next thing I'm going to do is I'm going to run a linear regression A plus BX, which is option 8. Now my calculator has the menu prompt. L1 from my X list, L2 from my Y list. We're going to store the regression equation so we can look at the graph. So I'm going to hit the vars button, go to yvars, function, y1. Now if you don't have the menu prompt, you just got to wait a few more seconds. And when I hit calculate, it will show me everything. Now I'm just going to quickly hit clear and pretend that didn't happen. If you don't have the menu prompt like I do, this is what your screen should look like. Lin reg A plus BX, L1, L2, Y1. and then you hit enter. It's going to calculate everything for us. So if I'm given this information, I'm asked for the least squares regression line. Remember, I'm not going to use y hat. I'm going to use my variables and my units. So I'm going to say height hat. The predicted height is going to be 71.95 plus 0.3833, I'll stop there, times the age. So there is my prediction equation. If I wanted to know my r squared, I could see my r squared is 0.9888 approximately, r is 0.9944 approximately. So I can write those down as well if I needed them. The problem doesn't ask us to, but I should be able to interpret what does my y-intercept mean. I should be able to interpret what does my slope mean. Again, this problem doesn't ask for it. Those are things we've done in previous problems. Now, if I continue on, it says use your regression line to predict Sarah's height at the age of 40 years, which is 480 months. Again, I'm going to pause to go through something. It was very nice of the prompt to tell us 480 months. But you're still expected to notice that our units are not the same and convert on your own. So be careful when you're reading. Make sure your units match. This was a nice prompt that told us 480 months is what we're going to use. I'm going to do that first. And if I continue reading, it wants me then to convert from centimeters into inches. So for C, the predicted height at 480 months is I would just plug in 480 for the age. Now I can have the calculator type this in and do it for me. I'm going to show you it this way. And so I'm going to have 71.95 plus 0.3833 times 480. And I get 255.934. But don't box that, don't circle it. The whole idea is be able to communicate what you're trying to say. And remember, this is in centimeters. We want it to be in inches. Now it says that 2.54 centimeters is 1 inch. So to convert to inches, I'm going to take the 255.934 centimeters, and I know that 1 inch is equal to 2.54 centimeters. So I'm going to divide 255.934 divided by 2.54. And I can just cross out the centimeters or cross out, I'll be left with inches. So I have 4 inches, the predicted height. Notice me going back to what we're finding is approximately 100.76 inches. Again, I'm not going to box that and circle that yet. I'm going to state this. I'm going to make sure the grader knows that I know what I found. The predicted height of Sarah at 40 years old, based on the least squares regression line, is about 100.76 inches. Now, the grader has no issues, exactly that I know what I'm talking about on it. There's another way to do this too, is when I stored it into Y1, it was placed into Y1 for me. And I already checked that my L1 is my X list, my L2 is my Y list. I'm going to go here. Stat plot is turned on. I have scatter plot, L1, L2 for it. So everything's there. So I can go, and I'm going to make my window. I'm not going to use these intervals because I want to see my y-intercept. So my min is 0 to 60, scale of 5, so I still have the same max. 0 to 100, just to round up. I'm going by tens. So the graph's going to look a little bit different, but generally it's the same idea. And I can see my least squares regression line along there. We can use this to calculate for us as well. So this is our answer for part C. D is asking us one other thing. It says the prediction is impossibly large. Explain why this happened. Well, 100.76 inches. Now that is a really large height. I mean, let's take a look. 100.76, I'm going to divide by 12. That's 8.4 feet on it. So the height is approximately maybe around 8 feet 4 inches, if you can do the conversion, or 100.76 inches total, which is too large. And the reason for this is because we used extrapolation. Now we can always just say, well, we use extrapolation and we could stop there, but you have to be able to explain what you mean by extrapolation. Is the linear pattern is not going to extend out to 40 years, 480 months. Our data is based on, we look at the age for it. I mean, this would be 3 years, 4 years. I mean, this would be up to 5 years right there. So it's only based on the ages. In the interval of 3 years to 5 years for Sarah. The linear pattern of the least squares regression line, it will not extend out. It will not continue. To 40 years. And we could also, I mean, some graders, some rubrics could look particular. We could also say, you don't grow every year the older you get. At some point, you do stop growing constantly on it. You're not going to grow the same height that you do from 4 years old to 5 years old when you're here it says 40, when you're 35 to 36. You're not going to grow that same continual height. At some point, the height increase each year is going to decrease, not be as high for it. So this is the answer to question 11. Be able to not just say the word extrapolation, but give context to it. Explain why the extrapolation does not work in this scenario for it.